You know, we spend a massive amount of time on this show talking about, let's call them the greatest hits of history.
The big names, yeah.
The people whose names are chiseled onto the marble facades of libraries. We talk about Socrates, we talk about Plato, Aristotle.
The rock stars.
They are the rock stars, the household names. I mean, you walk into a bookstore, if you can even find one anymore, their faces are on all the covers in the classics section. They're like the Beatles of ancient philosophy.
That's a very fair comparison. They really do take up all the oxygen in the room when we talk about Greek thought.
Exactly. But today we're going to do something completely different. We're going to veer off the beaten path. We're talking about a guy who, frankly, doesn't get the press he deserves.
Not at all.
He is not a household name. If you mentioned him at a dinner party, most people would probably think you were mispronouncing Alexander. But, you know, based on the stack of research we've gone through for this, he might just be the most important thinker you've rarely, if ever, heard of.
It's a bold claim, I know.
Mm.
But I'm inclined to agree with it. I mean, if we're looking for the specific moment in human history when we started to think differently, and I mean really differently, like a fundamental shift in our cognitive operating system, we have to look at this man. This is the moment humanity stopped looking up at the sky and seeing gods and started seeing machinery.
Oh.
We're talking about Anaximander of Miletus.
Anaximander. It's a great name. And the hook, for me, the thing that really grabbed me when I was prepping for this, is that modern scientists are obsessed with him.
They are.
We have Carlo Rovelli, a world-class theoretical physicist, literally calling this guy the first scientist, not one of the first, period.
And Rovelli isn't using that title lightly. You know, he's not just trying to sell books. He is making a serious argument that Anaximander represents the singularity of scientific thought.
Right.
So if you remember, we're going back to the 6th century BC. We're talking about 2,600 years ago. This is a world that is almost entirely defined by mythology.
Okay, let's set the stage for that. Because it's hard for us to really imagine now. We live in a world of cause and effect. But back then...
Back then, if there was thunder, it wasn't a low-pressure system colliding with a high-pressure system.
It was Zeus.
It was Zeus, and he was angry. If the ground shook, it wasn't tectonic plates shifting. It was Poseidon striking the earth with his trident.
If you got sick.
Apollo's arrows. The world operated entirely on the whims of powerful, invisible, and often very capricious entities. It was a world of personality, not physics.
And that's what makes Anaximander so wild. He looks at that world, a world of magic and monsters and, like you said, divine temper tantrums, and he just decides that because Zeus said so, isn't a good enough answer anymore.
Exactly. He's the figure who arguably invents the idea that nature follows laws.
Laws.
Impersonal laws, necessary laws, and most importantly, laws that are understandable by the human mind. He takes the gods out of the equation and replaces them with forces.
That is the mission for this deep dive. We are going to explore how one man initiated this massive shift. We're going to look at his map, which is a huge deal. I mean, literally drawing the world for the first time.
A world he could see as an object.
We're going to look at his concept of the infinite, which sounds kind of trippy, but is actually super logical. And we're going to talk about his ideas on evolution and space, which are surprisingly accurate and, let's be honest, sometimes completely bizarre.
Bizarre is a generous word for some of it, but yes. It's that perfect mix of genius and, well, what seems to us like madness.
Before we really jump in, though, we should clarify what we're actually working with here, because unlike Plato, where we have these beautiful, intact volumes of dialogues, Anaximander is a bit of a ghost, isn't he?
He is a puzzle with most of the pieces missing. We don't have his complete works. What we have are ancient testimonies.
So other people talking about him.
Exactly. Later writers, Aristotle, Theophrastus, Simplicius, Hippolytus, who were describing what Anaximander said centuries earlier. It's a bit like playing a game of telephone across 1,000 years.
But we do have something special, right? Something direct from the source.
We do. And it's so precious. We have fragments. Specifically, one significant fragment from his book on nature. And the very existence of this book is a milestone in itself.
Why?
It's considered the first philosophical prose ever written by a Greek.
And why does that matter? Prose versus poetry.
Oh, it matters a huge amount. Before Anaximander, wisdom was conveyed in poetry. You think of Homer's Iliad or Hesiod's Theogony.
Right, it's all epic verse.
And poetry is rhythmic, it's narrative, it's designed to be memorized and sung. It's about storytelling. Anaximander wrote in prose. That signals a total shift in intent. He wasn't telling a story about heroes. He was explaining a system.
He's not trying to be Homer.
He was writing a treatise. He was trying to be precise. not just evocative.
It's the difference between, I don't know, song lyrics and a user manual.
That is a perfect analogy. He was writing the first user manual for the universe.
So let's get into the context. We need to transport ourselves back to the 6th century BC. We're in the city of Miletus. Now, when I think of ancient Greece, I think of Athens, the Parthenon, men in togas debating democracy. But Miletus isn't Athens.
No, this is way before the golden age of Athens. Miletus was a city in Ionia on the coast of modern-day Turkey. And in the 6th century BC, Miletus was arguably the most vibrant, wealthy, and intellectual city in the entire Greek world.
So it was the place to be.
It was the New York City of the ancient Mediterranean.
A trade hub.
A massive trade hub. You had a harbor just teeming with ships. You had caravans coming in from the east. You had goods and people coming in from Babylon, from Egypt, from Phoenicia, from the Greek mainland.
And when you trade goods, you trade ideas.
Precisely. That is the key. Miletus was a melting pot. You've got Babylonian astronomers who have been charting the stars for centuries. You've got Egyptian surveyors who basically invented geometry to remeasure the Nile fields after the floods.
All these different knowledge systems.
And you've got Greek curiosity. All of it mixing together in this one harbor town.
It's interesting how often innovation happens in places like that. Places where different cultures crash into each other.
It forces you to question your assumptions. Think about it. If you live in a secluded village, everyone believes the same creation myth.
Sure, it's the only story you've ever heard.
But in Miletus, the Babylonians are saying the god Marduk created the world. The Egyptians say it was Adam. The Greeks say it was Gaia. And eventually, a smart person sitting in the marketplace starts to wonder, they can't all be right.
And maybe none of them are right.
Exactly. It breeds skepticism. And from that skepticism, you get the Milesian school. It starts with Thales. We have to talk about Thales because he was the teacher. He's often called the father of Western philosophy, and Anaximander was his student.
The master and the apprentice. So let's talk about Thales for just a second, just to establish the baseline. Thales is famous for one big idea.
All is water.
He thought everything was made of water, which, looking back from our perspective, sounds a little ridiculous. My desk is water. My dog is water.
It sounds silly to us, but you have to give Thales credit. He was trying to do something truly radical. He was saying that despite all the diversity we see in the world, trees, rocks, birds, clouds, it all comes from one underlying substance, a single arch.
The origin point.
He's looking for a grand unified theory.
And why water? Was he just, I don't know, thirsty?
No, it was observation. He saw that water is everywhere. It falls from the sky, it springs from the ground. Life needs it to survive. Seeds are moist.
Okay.
And crucially, water changes. It can be ice, which is solid, it can be liquid, and it can be steam, which is a gas. If you don't have a microscope or a periodic table, water is actually the most logical candidate for the fundamental stuff.
Okay, so credit where credit is due. Thales takes the first step. But here's where the Greek miracle, or what we might call the invention of science, really happens. Anaximander is Thales' student. He respects him, he learns the system, but then he disagrees.
That dynamic is the most important thing we will talk about today. This is what Rovelli really harps on. In so many ancient traditions, religious schools, or even other philosophical schools like the Pythagoreans later on, the whole goal is to preserve the master's teaching.
You memorize it.
You protect it. Ipsa dixit, he himself said it. That was the proof.
Unqualified acceptance. You don't question the guru.
Right? Or you have the opposite. Rival schools that just want to tear each other down. Unqualified criticism. You're wrong because you're not us. Anaximander introduced a third way. He deeply understood Thales' ideas. He appreciated the brilliance of seeking a single source. But then he said, I think you're wrong about the details, and I can prove it.
It's the birth of constructive criticism. It's the scientific method. I stand on the shoulders of giants so I can see further than they did.
Exactly. It's not heresy. It's progress. It's iteration.
So let's get into the argument. Why did Anaximander have a beef with the water theory? He didn't just say, I don't like it. He had a logical proof, didn't he?
He did, and it's a brilliant piece of logic. It's all based on the concept of opposites. In the ancient world, they understood matter through qualities. Hot versus cold. Wet versus dry.
The elemental cage match.
Right. And these qualities are mutually exclusive. Water is, by definition, wet and cold.
Okay.
Fire is, by definition, hot and dry.
Makes sense.
Anaximander argued that if the primary substance of the universe, the arch, was water, then fire could never exist.
Walk me through that. Why not?
Well, if everything starts as water, then the universe is infinitely wet and cold at its core. So where does the dry and hot come from?
Right, how do you get fire out of water?
You can't. If the source is infinite water, the wetness would be total. It would overwhelm any spark of fire before it could ever exist. Water destroys fire. They're opposites.
That is actually really solid logic. If the universe was just made of infinite water, we'd never have the sun. We'd never have heat.
Exactly. So he argued that the source of all things cannot be one of the things we see. It can't be water, it can't be fire, it can't be air.
Why not?
Because any one of those defined elements would destroy its opposite. So the source has to be something else, something neutral, something that lies underneath all the elements.
And this leads us to his big concept, the Apeiron.
The Apeiron.
It sounds like a Marvel villain. The Apeiron is coming. But what does it actually mean?
It's usually translated as the infinite, the boundless, or the indefinite. The Greek word paras means limit or boundary.
Okay.
Apeiron means without limit.
So try to visualize this for me. Is it a fog? Is it energy? What is it?
He posited that there's this primordial mass, ageless and deathless, that surrounds the entire cosmos. It isn't water, it isn't fire. It's the raw potentiality from which all things arise.
Oh, okay.
Think of it like clay
Mm-hmm.
or gold. You can make a ring out of gold or a necklace or a coin. But the gold itself isn't a ring. It's the stuff that becomes the ring. The Apeiron is the stuff that becomes the elements.
So it's this cosmic soup of undefined potential that just generates the universe.
That's a helpful way to visualize it. It encompasses everything. And because it's infinite boundless, it can keep generating worlds and life without ever running out. It solves the problem of where did fire come from?
Right.
It came from the Apeiron, just like water did. They are siblings, born from the same mother.
That's surprisingly abstract for a guy living 2,600 years ago. He isn't pointing at a river or a mountain. He is inventing a metaphysical concept to solve a logical error in his teacher's theory.
And he backs it up with what is essentially a law of conservation. We actually have that surviving fragment of his writing, the only direct quote we have that explains how this works. It is one of the most famous sentences in all of ancient philosophy.
I have it right here in the notes. I want to read it slowly because
Right.
it sounds like poetry, but you're telling me it's physics. He says, "Whence things have their origin, thence also their destruction happens according to necessity. For they give to each other justice and recompense for their injustice, in conformity with the ordinance of time."
It just gives you chills. It's beautiful.
It is beautiful, but let's be real, it's also pretty cryptic. Justice and recompense for their injustice. What on earth is he talking about? Is nature committing crimes? Is a rock committing a felony?
No, not quite. You have to remember, he doesn't have the vocabulary of modern science yet.
Right.
He doesn't have words like thermodynamics or equilibrium or conservation of energy. So he uses the language he has, the language of law and society, words like dike justice.
So translate the metaphor for me. What is the injustice?
Think of the elements as being at war for territory. Let's take the seasons. Summer is hot and dry. In the Greek view, when summer is dominant, it is committing an injustice against winter, which is cold and wet.
Okay, so summer is taking up too much space. It's encroaching.
It's aggressive. And necessity and time are the judges. Time forces summer to pay recompense by yielding to winter. The pendulum has to swing back. Nothing can dominate forever.
So it's a cosmic balancing act.
He's describing a state of dynamic equilibria. If one element takes too much, it has to pay it back by being destroyed or receding.
That sounds a lot like Newton's third law. Every action has an equal and opposite reaction. Or just the general idea of equilibrium in physics. Energy in, energy out.
It is the ancestor of those ideas. It's the concept that the universe is a closed system where checks and balances are enforced. But they aren't enforced by Zeus throwing a lightning bolt because he's in a bad mood.
No, it's automatic.
They are enforced by the ordinance of time. It's an impersonal mechanical process. The sun must retreat in winter, not because it wants to, but because it is necessary.
That distinction, personal versus necessary, that's the whole game, isn't it?
It is. It's the shift from God willed it to that's how the machine works.
No, I saw in the notes that some people take a much darker view of this fragment. Friedrich Nietzsche, the German philosopher, apparently had a field day with this one.
Oh, yes. Nietzsche loved the pre-Socratics.
Ah.
But he interpreted this fragment through a very pessimistic, very Nietzschean lens. He thought Anaximander was saying that existence itself is the crime.
Wait, what? Just being alive is the injustice.
According to Nietzsche's reading, yes. By separating from the eternal unified Apeiron and becoming an individual thing, a person, a rock, a season, you are breaking the unity. You've been committing an injustice against the whole just by being an individual.
So your death.
Your destruction, your death, is the penance you pay for the sin of having been born.
Wow. That is incredibly bleak. Sorry for existing. I'll make up for it by dying.
It's very dramatic. It turns the universe into a Greek tragedy.
Mm.
But I should say, most modern scholars, like Rovelli and others, they lean more toward the equilibrium interpretation.
That makes more sense.
It's about the balance of physical forces, not a moral judgment on the tragedy of existence. It's physics, not original sin.
That seems to fit better with the rest of his work. He doesn't seem like an emo philosopher weeping about existence. He seems like a guy trying to figure out how the machine runs.
Exactly. And speaking of the machine, we have to talk about the Earth. Because this is where Anaximander completely blows my mind. This is the moment where the bottom drops out of the ancient world.
This is the floating Earth theory. Okay, let's look at the before picture. Thales, the water guy, he thought the Earth floated on water, like a log or a raft.
Which was a very common view in the Near East and Egypt. It makes intuitive sense, right? It explains why the ground feels solid. But we have earthquakes. Maybe the water underneath is rocking like a ship in a storm.
But there's a problem with that, a big logical trap.
The infinite regress problem. If the Earth rests on water, what does the water rest on?
A bowl, a rock,
And what does the rock rest on?
a turtle.
And the toad.
It's turtles all the way down.
Exactly. You eventually run out of supports. You just keep pushing the problem down one level. And Anaximander saw this logical trap, and he just stepped right out of it. He did something completely unprecedented. He proposed that the Earth floats in the center of the infinite. It rests on nothing.
I want the listener to really pause on that image. We are in the 6th century BC. There are no telescopes, no satellites, no pictures of the blue marble from space. And this guy stands up and says, hey, everyone, the Earth is just hanging there in empty space. It's not sitting on anything. I mean, why did he think it didn't fall?
He used what we call the principle of sufficient reason, or sometimes it's called the logic of indifference. He argued that if the Earth is truly in the center of the universe and the universe is uniform all around it,
Then there is no reason for it to go left or right or up or down.
exactly, it is equidistant from everything, why would it fall down? In the cosmos, there is no down. Down is just the direction toward the Earth. But the Earth itself has no preferred direction to travel in the void. It stays where it is because of equilibrium.
That is a staggering leap of abstraction. He realized that down is relative. He realized that space doesn't have a bias.
Karl Popper, the famous philosopher of science, called this one of the boldest, most revolutionary, and most pretentious ideas in the whole history of human thinking.
It really is. It frees the Earth. And once you free the Earth from resting on roots or pillars or water, you open the door for astronomy, for real astronomy.
Yes. That's the key consequence.
Yeah.
Before this, you had a huge problem. Where does the sun go at night?
Right.
It sets in the west, and then it rises in the east.
Yeah.
How did it get back? Did it sneak back around the side? Did it float on a river? Did a god carry it in a boat?
Because it couldn't go under the Earth. The Earth was sitting on something.
Exactly. But now, Anaximander can say, it goes under us. Because the Earth is floating, the stars and the sun can pass underneath the Earth. It allows for a full 360-degree model of the cosmos.
The Earth becomes an object suspended in space.
It's the moment the universe became 3D.
It really is. Now, before we give him a Nobel Prize, we have to talk about the shape of the Earth. Because while he got the floating part right, he didn't quite get the shape right.
No.
He didn't think it was a sphere.
No. He thought it was a cylinder.
A cylinder, like a soup can.
Like a column of stone. A drum. He believed its height was 1/3 of its diameter. And we live on the flat top surface.
Okay, so it's a flat disk, but with thickness. Why a cylinder? I mean, why not a box? Why not a sphere?
Well, he probably looked around and saw the horizon look flat. So the flat Earth part comes from direct observation.
Sure.
But he needed it to have depth to be a stable object.
Yeah.
The column is a sturdy shape. It feels significant. And you have to remember, Miletus is full of stone columns. It's a familiar architectural shape.
So we are living on the top of a giant cosmic column floating in the void.
Precisely.
It's still a huge step up from a floating log. So we have this drummer thinking in the void, what's going on above it. Because his map of the heavens is, well, it's mechanical, which is cool, but it's also wildly different from what we know.
It is the first mechanical model of the universe. He moves away from gods driving chariots to wheels of fire.
Wheels of fire. Let's unpack that. That
Yeah.
sounds like some heavy metal imagery.
It is quite metal. He imagined that at the beginning of the world, a ball of flame surrounded the Earth like bark on a tree.
Ooh, that's a great image. A cosmic skin.
And then this ball of flame broke apart and formed into rotating rings or wheels surrounding the Earth.
Okay.
These wheels are hollow, they're opaque, made of a dark, misty air. But they're filled with fire.
So giant hollow donuts filled with fire.
Correct. And we can't see the fire directly because of the mist, but there are holes in the wheels, vents, or as he described them, like the hole in a flute or a nozzle.
And the fire shines through these holes,
Yes.
and that's the sun.
That is the sun. The sun isn't an object, it isn't a god, it isn't a rock. It is a hole in a giant fire wheel that lets us see the fire inside.
That is fantastic. It explains why the sun is so bright. It's pure fire. What about the moon?
Same thing. A different wheel with a hole and the phases of the moon.
Let me guess. The hole is opening and closing.
That's it. Like a shutter on a camera.
Then an eclipse.
The hole gets completely blocked.
It's so mechanical. It's cosmic plumbing. It's not a god getting angry and hiding the sun. It's a nozzle getting clogged or a shutter closing.
That's the genius of it.
Yeah.
He is looking for a mechanism. He even tried to calculate the sizes. He said the sun wheel was 27 or 28 times the size of the Earth, and the moon wheel was 19 times the size.
He's using numbers. He's using ratios. He's trying to quantify the cosmos. Why those numbers, though? 27, 19. They seem a little random.
They aren't random to a Greek. They are multiples of 3 and 9. They're sacred or mathematical ratios. Even if the numbers were wrong, and they were very wrong, the fact that he felt the need to use numbers is the breakthrough. He is claiming that the universe has a mathematical structure.
He's trying to decode the blueprint.
And he also realized that these things are far away. He's the first to conceive of depth in space.
Yeah.
The stars aren't painted on a dome just above our heads. They are wheels at massive distances.
But he got the order wrong, right?
He did. This is one of the bizarre parts. He thought the stars were the closest wheels to Earth, then the moon, and the sun was the farthest away.
So stars, then moon, then sun. Why would he think the stars are closer?
We aren't entirely sure, but perhaps because the fire of the sun is so intense, he assumed it must be on the largest, most massive wheel way out there. Or maybe he thought the sheer number of stars meant they had to be on the smaller inner rings. But again, the details matter less than the structure.
The big idea.
The big idea.
Yeah.
Celestial bodies at different distances operating by understandable laws.
This theme of laws just keeps coming up. It extends to the weather, too. I mean, if you live in ancient Greece, thunder and lightning are the domain of Zeus. That's his brand. That's his logo.
It's his whole deal.
And Anaximander says, actually, no.
Right. He demystifies the weather completely. He says thunder and lightning are caused by wind.
Wind? How does wind make lightning?
Well, he believed that wind gets trapped inside thick clouds, it builds up pressure, and eventually it bursts out violently.
Okay.
The ripping of the cloud is the noise. That's the thunder. And the rift in the cloud reveals the fire or the glow inside. That's the lightning.
So it's like a balloon popping.
Exactly. It's a physical interaction of elements. Air and cloud. No God required. It's a pneumatic explanation for a divine phenomenon.
He really was stripping the magic out of everything, wasn't he?
He was stripping the caprice out of it. He wasn't removing the wonder. He was removing the idea that it happened because someone was angry.
He also had this theory about the sea drying up, which feels weirdly prescient given our current conversations about climate change, although his reasoning was totally different.
He believed the Earth was originally much wetter, that it was once covered in moisture. The sun is slowly drying it up.
So the oceans are shrinking.
Right. The sea is just the remnant of this primordial moisture. And rain is just moisture that the sun has pumped up, which then falls back down.
The water cycle.
Essentially, yes.
Right.
He described evaporation, and he predicted that eventually the sun would dry up the sea completely.
So a slow, inevitable desiccation of the planet. Cheerful guy.
A realist, perhaps. He likely saw that the coastline of Miletus was changing. The river meander was silting up the harbor. He just extrapolated that local drying to a global scale.
But speaking of beginnings, we have to talk about where we came from. Because Anaximander's thoughts on the origin of life are, frankly, shocking. He basically invents evolution 2,400 years before Darwin.
Proto-evolution is a fair term. And what's brilliant is how he gets there. He doesn't have fossils in the way we do. He starts with a simple observation about human babies.
We're useless.
They're helpless.
Yeah.
Extended infancy. Think about a horse or a cow. A foal can walk within minutes of being born. It can run. It can feed itself pretty quickly.
Yeah.
A human baby, it can't lift its head. It can't eat solid food. It needs intense care for years.
It's true. We are born half-baked.
And Anaximander looked at that and said, wait a minute. In the primeval, harsh world, If the first humans had appeared as helpless infants, they would have been eaten or died of exposure immediately.
So Adam and Eve couldn't have just popped into existence as babies. They wouldn't have survived the first night.
Right, so he concluded that humans must have originated from something else, something that grows up faster, something that could protect them while they were vulnerable.
And his answer was fish.
Fish, or fish-like creatures. He believed life began in the moisture, in the sea, triggered by the heat of the sun. The first creatures were covered in a spiny bark, maybe scales or a shell.
Okay, so life starts in the ocean? Check. That aligns with modern science.
Then, he argues that humans grew inside these fish-like creatures. We were held prisoners inside them, protected, until puberty.
Wait, until puberty. So we were just hanging out inside a giant fish for like 12 years.
That was his theory. We stayed inside until we were strong enough to feed ourselves. Then the fish burst, and humans emerged onto dry land, ready to survive.
That is wild imagery. It sounds like a Cronenberg movie, or Alien.
It does. But the logic behind it is impeccable. He identified a biological constraint, infant vulnerability, and he hypothesized a biological solution for it.
Gestation in a different host.
It connects humans to the animal kingdom. We aren't separate creations of a god. We are part of a lineage that came from the sea. That is a massive conceptual leap. He just missed the mechanism of natural selection and replaced it with bursting fish.
Which, given the tools he had, is forgivable. He figured out adaptation, he figured out origins, he just missed the how.
Exactly. He deduced the history of life from the frailty of a child.
So we've got the infinite void, the floating drum earth, the fire wheels, and the fish people. This guy is batting 1,000 on creativity. But Anaximander wasn't just a theorist sitting in an ivory tower. He was a practical guy.
A leader in Miletus, yeah.
And he is credited with making the first map.
The first map of the entire inhabited world. Now, Babylonians had maps, but they were often local property lines, cities, or strictly symbolic. Anaximander attempted to draw the whole known world, Europe, Asia, and Libya, which was their word for Africa.
Why is that such a big deal? I mean, we take maps for granted. We have Google Maps in our pocket.
Because to draw a map of the world, you have to adopt a God's eye view. You have to mentally lift yourself out of your physical location and imagine looking down on the earth from above.
It's a feat of abstract thinking.
It really is. You're converting the world into an object that can be seen and measured.
It's not just turn left at the big rock. It's this is the shape of the landmass.
Exactly. It visualizes the world as a graspable object. It was likely a circular map with the ocean flowing around the outside the river Oceanus. Miletus or maybe Delphi would have been right in the center.
And this wasn't just for fun, for philosophy. Miletus was a trade hub. This was useful.
Incredibly useful. For navigation, for trade, for politics. If you want to found colonies on the Black Sea, which Miletus did extensively, you need to know where it is relative to you. Knowledge is power, and a map is a tool of control and expansion.
He also introduced the gnomon to Greece.
The gnomon. It sounds fancy, but it's a simple vertical rod, a stick in the ground.
Yeah.
The Babylonians probably invented it, but Anaximander refined its use in Greece.
It's basically a sundial stick.
Yes. But it's not just about telling time. By measuring the shadow, you can track the seasons. The shadow is longest on the winter solstice when the sun is low, and shortest on the summer solstice when the sun is high.
And I read that he used this to determine the equinoxes with real accuracy.
Which requires geometry. It implies he wasn't just sticking a stick in the ground. He was understanding the geometry of the sun's path across the sky. He was modeling the heavens.
There's also this story about an earthquake. Cicero mentions it. Apparently, Anaximander warned the Spartans to sleep outside because an earthquake was coming.
And lo and behold, the city collapsed and part of Mount Aegisthus split off.
How? Did he have a magical sense? Was he a mystic? Or was he just incredibly lucky?
Well, Cicero and others debate this. Some called it admirable inspiration. But if we look at Anaximander's character, the naturalist, the observer, it's far more likely he was observing natural signs.
Okay.
Maybe the strange behavior of animals, maybe the release of gases from the ground, maybe the water levels in wells changing. He believed nature followed laws. If an earthquake is a physical event, it might have physical precursors.
So even his magic trick was probably just really good observation.
Exactly. He was paying attention to the world, not the omens.
I want to zoom out a bit to his legacy. We've covered a lot of specific theories, but what is the big picture here? There's a note in our source material about the plurality of worlds.
This connects right back to the Apeiron. Since the source of all things is infinite, Anaximander, and later the atomists, believed that our world isn't the only world.
The multiverse.
In a sense, yeah. He believed that worlds are constantly appearing and disappearing within the Apeiron. Infinite worlds in an infinite time frame, like bubbles in a cosmic foam.
That is mind-bending. It makes you feel very small.
And that's a very modern feeling. Science often does that. It displaces us from the center. Copernicus moved the Earth from the center, and Anaximander moved our entire world into a sea of infinite other worlds.
But let's go back to that idea of the scientific method. We touched on it with Thales, but I want to dig a little deeper here. Carlo Rovelli makes a really strong case that Anaximander invented the process of science.
Rovelli argues that Anaximander initiated a tradition that is unique. It's the ability to say, I value your knowledge, but I think you are wrong about this specific detail, and here's why. It is the institutionalization of criticism.
It's not heresy. It's progress.
Precisely. In many ancient cultures, Egypt, Babylon, China, questioning the cosmological order was dangerous. It was an affront to the gods or the king. Stability was the goal. Anaximander and the Milesians in general created a safe space for intellectual rebellion.
How?
They stripped the gods out of the equation and replaced them with forces. Once you remove the god, you can criticize the theory without being a blasphemer.
That is a crucial distinction. If the sun is a god, analyzing it is rude. If the sun is a hole in a wheel of fire, analyzing it is just mechanic.
Exactly. He made the world safe for analysis. And he used familiar terms to explain unfamiliar concepts. He translated mythology into physics. He didn't just tear down the old house, he built a new one using some of the old bricks, words like justice and time, but with a completely different architectural plan.
And we see echoes of him even in modern quantum mechanics, apparently.
We do. The physicist Max Born actually suggested that the primordial substance of quantum mechanics, the underlying field from which particles pop in and out of existence, should be called the Apeiron.
No way, really?
Yes, because, like in Anaximander's Apeiron, the quantum field is indefinite. You can't observe it directly, but it's the source of all observable reality. It defies standard definitions of matter, just like the Apeiron did.
That is a direct line from 600 BC to the 20th century.
It shows that the fundamental questions haven't changed. What is everything made of? How did it start? How does it stay balanced? Anaximander was the first to frame these questions in a way that science could eventually try to answer.
It's incredible. He floats the earth in a void. He evolves humans from fish. He replaces Zeus with natural law. He essentially lights the match that becomes the torch of science.
And he does it all while living in a time when most people were, afraid of the dark.
So what does this all mean for us? Why does Anaximander matter today other than as a really cool history lesson?
I think he matters because he teaches us courage, intellectual courage. It takes bravery to look at the world, see everyone believing one thing, that the earth sits on water, that Zeus throws bolts, and to say, I think it works differently. It takes bravery to accept that the earth isn't resting on a sturdy foundation, but is floating in nothingness. He was comfortable with uncertainty. He was comfortable with the infinite.
He wasn't afraid of the vastness. He didn't need the comfort of a turtle to rest the world on.
No, he embraced the void. And that is the spirit of exploration, isn't it? You have to leave the safe harbor to find the new world.
That is a great takeaway.
There is one final thought I'd like to leave you with, a provocative thought based on his surviving fragment.
Let's hear it.
We talked about his fragment, about existence paying penance to the infinite. If Anaximander is right, and everything that exists, you, me, the stars, the earth, is just a temporary theft from the infinite Apeiron, a momentary disruption of the eternal silence, then we're a fleeting injustice, a beautiful temporary imbalance, and eventually we have to pay the debt. We have to return to the source. It suggests that our existence isn't the point of the universe. The point is the balance. We are just the noise in the system.
That is both terrifying and oddly comforting. We're just borrowed stardust waiting to be returned. We're part of the cycle.
Exactly.
Well, on that existential note, this has been a fascinating journey into the mind of the first scientist, Anaximander of Miletus, the man who saw the infinite. Thanks for diving in with us.
It was a pleasure.
And thank you for listening. Keep looking up, keep questioning, and don't be afraid of the void. We'll catch you on the next deep dive.